Okay, so today in 7.6 we're going to explore radical equations. So the first steps that you would need to write down is isolate the radical. Isolate, get it by itself before you solve anything else, before you do anything else. The second one is we're going to square both sides of the equation to solve for x. Now the reason I put square into quotes because sometimes you're going to have to cube both sides or take both sides to the fourth power, to the fifth power. So I put that in quotes for that reason. And the last step is always check for extraneous solutions. All right, so let's begin. The first one, there is no radical that needs to be isolated. So it's already done for you. So we're going to go right to the second step by squaring both sides because this is a square root. That's why we're squaring both sides. And when you square root something squared, what ends up is what's left over. And 9 squared is 81. So we continue on getting 3y equals 80, and y is going to equal 80 over 3, and nothing else we can do with that. Now if we're going to check for extraneous solutions, we would take the 80 over 3 and plug it in for y in this case. So, and that's supposed to equal 9 plus 1. Okay, the 3's would cancel, giving you 80 plus 1. Square root of that is square root of 81 is 9. So that checks out. I know it is the correct answer. So I'm going to go ahead and get rid of that. The next one, the radical is not by itself. So we are going to we're going to divide both sides by 8 first. That way the radical is by itself. And that reduces to 1/4. And by squaring both sides, we'll be able to isolate the y. And squaring 1/4 is 1/16. Okay, now to check the answer. 8 times 1/16, square root of 1/16, is supposed to equal 2. So we are checking that to be correct. Square root of 1 is 1, square root of 16 is 4. And when you multiply those together, it'd be 8/4, which is 2. So that also is correct. I know for sure that it works. Okay, when you have the radical in the denominator, let's just place a 1 underneath the 3 and cross multiply. So 1 times 1 equals 1, and 3 times radical y. And we can begin the steps that we learned in the previous slide. So get the radical by itself, and now that we have that, we're going to square both sides to get 1/9 equals y. Okay, and you probably already have this written down, so I'm going to go and check my answer. 3 equals 1 over square root of 1/9. And it would be 3 over, and that's a perfect square, 1/3. And 1 divided by 1/3 is 3. So that also is the correct answer. Okay, let's go on to the next one. The radical is already isolated, so I'm going to go right to squaring both sides to get x plus 3 on one side and 36 on the other for an answer of 33. And let's pause and check our work. So let me get a different color to do so. 33 is supposed to go in for x. Square root of that is supposed to equal 6. And it looks like we are good to go on that. Okay? And on the next one, we have to isolate the variables by adding 7 to both sides. So I'm left with square root of x minus 2 equals 3. Squaring both sides will give you x minus 2 all by itself, and 3 squared is 9. So x is going to equal 11. So let's check our answer. 11 minus 2 minus 7 is supposed to equal -4. This is 9, and that's 3, and it looks like we have a match. So that also is the correct answer. X equals 11. Okay, go ahead and try the next one by yourself by pushing pause. Now that you're back, since we have two different radicals, we're just going to go right to squaring both sides. Now, since there are two things in there, we can square the 2, and we can also square the radical that's inside. So you have the 2y minus 3 left over equals 4y. Distributive property tells us that 8y minus 12 is going to equal 4y. And then if we get everything to one side, all the y's on one side and all the numbers on the other, I get y equals 3. And if I'm going to check the answer, it would be 2. Radical 2 times 3 minus 3 equals 4 times 3. So 2, and then 6 minus 3, this is 12. And if I break that down, it would be radical 4 and 3, and we have a match. So now I also know that y equaling 3 is correct. Okay, let's go on to the next one. Very similar to the previous one. We have to go right to squaring both because there are two radicals. This is going to be y plus 10. This is going to be 9 because we are squaring the 3 and squaring the radical. So y plus 10 equals 18y plus 27. And 17y equals a negative 17, it looks like. And so y is going to equal negative 1. If we're going to check our answer, it would be negative 1 plus 10 in the square root symbol, 3, and then 2 times negative 1 plus 3 in the square root symbol as well. So that's square root of 9. This is negative 3, so that's just 1 inside. That's 3, and that's 3 times 1. We've got our answer is correct. All right, very well then. Let's go on to the next one. The radical is by itself, so we can go right to squaring both sides. And we end up with y minus 3 equals 4, and y equals 7. And if we're going to check our answer, it would be 7 minus 3. I'm sorry, I'm ahead of myself here. 7 minus 3 equals negative 2, which is 4, and we're only using the principal square root, so we do not have a match. Okay, so when that happens, that means that this answer is extraneous. So you can write that on the side of that solution. It is a solution, but when you plug it in, it doesn't work, so that is considered extraneous. And then the last one is a cube root. So instead of squaring both sides, we're going to cube both sides, because if a cube root of a cube is going to end up by its lonesome, and you get 27 and 29 for an answer. Let's see if it works by checking our answer into the original problem. Cube root of 29 minus 2 equals 3. Cube root of 27 indeed is 3, so we have a match. X equaling 29 is the correct answer, and that is all I have for today. So, see you tomorrow.